Okay, so continuing our discussions, we have here the inductors. Okay, so this is supposedly considered as a week 8 lectures, no? So giisa na lang natin yan siya para wala na tayong problema. Okay, so we have here inductors, no? So kanina we have discussed the how is the characteristic and performation or combination of capacitors. Okay, so right now we will be having these inductors, no? um, but most probably it has a same property when it comes to comparing the two circuit elements, but sometimes, no, sometimes we can actually neglect, or uh, we can sometimes we cannot have the same operation with that of the capacitor. Okay, but it has the same characteristic actually. So we have here an inductor. An inductor consists of coil of conducting wire. So we have here this form of conductor, no? So it has if you have a coil of inductor, a coil of conducting wire, so you can form an inductor. So we have here the value of voltage across across the inductor. We have voltage equals to LDI over dt. So if you remember, the value of the current across the capacitor is equals to I is equals to CdV over dt. So if you can imagine, they are opposite, no? So sa capacitor, ang nakalagay dito is current, sa inductor naman ang nakalagay dito ang sa capacitor ang nakalagay dito is voltage. Okay? So inductance is the property whereby an inductor exhibits opposition to the change of current flowing through it, measured in henries. Okay, so we have here an inductance. Okay, usually, no, this is the definition of inductance. No, we can actually use this one for most of the time, no. Okay, so we have here if you take this um formula inversely, so we can derive this formula. We have di is equals 1 over lv dt. So if we take the integral of that one, so we can actually find the summation of all the current inside or flowing to that inductor. Okay, so we have here I is equals 1 over l integral of v of t, expression of v of t here, v of t dt plus I of t sub o. So where this is the initial value of the current through the inductor. Okay, so we have here also the equation or formula for the energy. So we have here energy is equals to integral from negative infinity to t of power dt, where power is given by the multiplication of current and voltage. So here the current and this is the voltage. Okay, so we can actually have that the value of final value of the energy, we have 1 half Li squared. Okay, so we have here an inductor acts like a short circuit, no? So this is also important, no? Same as doon sa capacitor, an inductor acts like a short circuit to DC. Okay, so ibig sabihin it is being when you perform an operation, when there is a stable supply of that inductor, so we can perform as a short circuited. Okay, doon sa capacitor natin is open circuited, remember, no? So the current through an inductor cannot change instantaneously, same as those the value of voltage across the capacitor. Okay, it cannot change abruptly, same as this one. It cannot the current also cannot change instantaneously. Okay, so we have here an example, no? The current through 0.1 Henry inductor is I of t is equals to 10t e to the power of negative 5t ampere. Find the voltage across the inductor and the energy stored in it. Okay, so we have this equation. We have this value. Okay, so we can use this formula in order to find the value of voltage, no? So we have here V multiplied by the inductor, the value of inductor is 0.1, then the derivative of this expression of I of t. Okay, then after that we can now find this equation. Okay, then in order to find the value of energy stored, we can use this equation, 1 half Li squared. Okay, so I natin is ito, then L natin is yung 0.1. Okay, so ito na yung energy natin. So we have here practice problem. So please answer this one. No, same as that stated above. Okay. So we have here example number 9. So find the current through a 1 millihenry inductor if the voltage across it is equal to this one. So we have here the meaning of this equation is that if t is greater than 0, okay, so this is supposedly mali, no? It should be less than, no? This would be if t is less than 0, no? If t is greater than 0, the value of the voltage is this one, and then if t is less than 0, the current is, or the voltage is 0. So also find the energy stored within 0 to 5 seconds. We have here um, the value of current is or the formula in order to find the current through a inductor, we have to use this equation. Okay, so given that the inductor is 5 Henry, okay, so we have here uh, okay, I is equals 1 over 5. I think this should not be 5 millihenry, 5 Henry. It should be 1 millihenry. Okay, so please recalculate that one, no? But same as this formula that has been used, no? And the only variation that you can make is that uh, changing the value of this 5 Henry into 1 millihenry. Okay, so but all in all, we have the same formulation of a solution. So we have here the practice problem. So please answer this also. So we have here example number 10. So we have considered the circuit in the figure here. Under a DC condition, find the I, the value of current, the value of voltage across the capacitor, and the value of current across the inductor. The energy stored in the capacitor. So, okay, so remember, no, as I have said, in a stable connection of inductor and capacitor in series with the source voltage, no, or in connection with the source voltage, the capacitor behaves like a open circuited and the inductor behaves like a short circuited. So if that will happen, no, so you can just configure this out, no, same as this circuit here, no. So we have here short circuited yung current natin, so connected, then yung capacitor natin is naging open circuited din siya. Okay, so wala na to. Okay, so in order to find the value of current here, no, you have just to have the KVL here in order to find the current. And then IL is also equal to this I, no? So, yun lang naman yun siya actually, no? Madali lang naman siya. Okay? So, we have here series and parallel connection of inductors. So, sa connection of inductors, in order for you to find the value of equivalent, no, when you have a series combination of inductors and parallel combination of inductors, you will just have to perform same operation with the resistance, no? Yung kanina sa capacitor natin, in order for you to find the equivalent, uh, we have the opposite calculation. Yeah, when opposite calculation with the uh, resistance. Dito sa inductor natin, we have to use same as how we can have the equivalent of series and parallel connected resistance. Okay, so as you can see here, if you have a parallel connection of inductance, we have this operation. And if you have a series connection of inductance, you will just have to add that one. Okay, so yun. So we have here, no, example in order to find the value of. So we have the summary of calculation of inductor and capacitor, no. So please refer on it. In here, we have here an example on how to find the equivalent of inductance. Okay, so I think this conclude our discussion for week 7 and week 8. If you have any question regarding on this one, please ask it to me right before the exams, no. So or you can just go to my office if you have any question, and then let us discuss it further, no. So that's all. Assalamualaikum warahmatullahi wabarakatuh.